In this video, I want to go over some common pitfalls for new Python developers. And the first one that I want to cover is using a mutable default argument such as a list or a dictionary. The problem is with a mutable default argument, if it's modified within the function, the changes persist across multiple function calls. And what I mean by that is you'll see here that I have a function that adds an item. And it takes two parameters. One is an item that is required, and then a list that is not required and uses a default empty list. And then in the function, we simply take the list and we append the item that we pass into it, and then we return the list with the appended item. Now, because I am using a mutable default argument, when I call this function 3 separate times, it is going to keep referring to the same list instead of creating a new one. So when I run this, by the time I get to my third function call, I am putting 3 items in that same list when I only want to put 1 item in that list each time I call it. So to correct this, we would use none for our default value for list. And then in the function, we would check to see if my list is equal to none, and then set my list to equal an empty list. And now inside the function, it will create an empty list and append the item to it and then return that list. And because it's not using the default value, it will not constantly refer to the same list. So when I run this now, we'll see that my return is a list containing a single item like I expected it to. The next thing that I want to go over is modifying iterables during iteration. Modifying an iterable such as a list or a dictionary while iterating over it can lead to unexpected behaviors or errors. And if you do need to modify an iterable, it's better to create a copy or use something like list comprehension to generate a new iterable. And to show an example of that, I have this list of animals here containing 4 animals, and then I have a for loop that is going to iterate over the animals, print them out, and then if the animal is equal to lion, I want to remove it from the list. Now when I run this, we're going to get the output kangaroo, lion, and bear. And what you'll notice is it did not output tiger. Now the reason that it did not output tiger is because when it got to lion here and it removed lion, these indexes changed. So the first time it went through, it was at index 0 and it output kangaroo. The next time it was at index 1 and it output lion, but then because the animal was equal to lion, it removed it. And once it removed it, before the next iteration started, tiger was moved to index 1 and bear was moved to index 2. So on the next iteration, the index was at 2, which was now bear, and completely skipped over tiger. So what you would want to do in this situation, or at least one way to do this, there would be many ways to correct this particular error, is you could iterate over a copy of the list rather than the list itself, but then perform whatever changes you want on the actual list. And the way that I'm going to iterate over a copy of the list is simply by using slice notation. So I'm going to put in square brackets and a colon, just like that. And now this is a copy of the animals list, not the actual animals list. So when I remove this animal from the list, it's still going to correctly print them in order. And when I run that, we'll see that I get kangaroo, lion, tiger, and bear. And if I want, I can down here just print my animals list just to show that lion was in fact removed from the list. Another common problem is unintended variable references. For mutable objects, Python uses references to the object, and assigning one variable to another does not create a new copy of that object. Modifying one variable can affect other variables that reference that same object, so it's important to understand object references and use techniques like copying or creating new objects when needed. So I'm going to show an example of this. I have 2 lists here, list 1 and list 2, and I have list 2 equaling list 1. So now if I do list2.append 4, and then print out list 1, which you'll see here, I'm printing out list 1, we'll see that list 1 has changed as well, even though what I modified was a list 2. So real quick, I'm going to comment that code out so it doesn't run. And when I run this, we'll see it says list 1 after appending 4 to list 2, and we'll see that we do have 4 in that list. Now this is not an issue for immutable objects such as integers or strings, and we'll see that here, that I have x equals 10, and then y equals x, and then I change y to equal 20. But if I print this out, we'll see that x is still equal to 10. And right here, x after changing y to 20, and it's outputting the value of x, which is still 10. So if you're using mutable objects such as lists or dictionaries, just be mindful that if you set a variable equal to one of these mutable objects, you are creating a variable that's referencing the same object in memory. It is not creating a copy of that object. Another common issue that is somewhat circumstantial is mixing tabs and spaces for indentation. Many interactive development environments insert spaces whenever you use the tab key. Not all of them do. So if you're using a mixture of spaces and tabs, depending on how you open that file up or what program somebody else uses to open that file up, it could throw the indentation and spacing way off and just completely ruin the file and make it a pain to have to get all the tabs and spaces in order again for the file to execute. So just make sure that when you are writing code that you are consistent with your tabs and spacing. What I like to do is just set up whatever editor I'm using to insert 4 spaces whenever I do hit the tab key. Another thing that new developers often forget to do is handle their exceptions properly. So whenever you have code that could have an exception, like anything that involves input from a user, you either have to make sure that you are validating that input either using error handling or some other way, but just make sure that anywhere in your code that an exception could happen, that you are using a try except block to handle it if it does, so that it doesn't crash your program. And the last thing is a reminder on floating point precision, because the way that floating point numbers are represented in computers, performing calculations with floats can sometimes lead to unexpected results. And I will give a quick demonstration for that. So I will have x equals 0.1, y equals 0.2, and I will say z equals x plus y. And if I print z out, I'm not going to get 0.3 like you would expect. I'm going to get 0.3 and then a whole bunch of zeros and then this 4 on the end of it, because it is slightly imprecise. I mean, this is an extremely small, imprecise amount, but depending on what you're doing, this might actually matter. So just be aware that when you're using floating point numbers, they're not always perfectly accurate.